You're all familiar with recommender systems, I'm pretty sure about that. Be it that you have been shopping on Amazon, that you use Netflix, Spotify, or even on Facebook. Recommender systems are pretty much everywhere. Not only in e-commerce and social networking, also in digital libraries. If you have an account on Google Scholar, for instance, you will see recommendations once in a while. If you use software like Mendeley, you will get recommendations by email typically. And there are many examples more. Unfortunately, in our world, in the digital library world, there are not so many recommender systems. Some digital libraries have, but many don't. And the main reason for this is probably it takes a lot of time and skills to develop recommender systems. And I'm going to talk about a system or a product that I developed that helps digital libraries to integrate the recommender system very easily in their library catalog. Before I introduce the system, let me introduce myself very briefly. As Declan mentioned already, I'm an assistant professor here at Trinity and the Adapt Center. I started here 3 years ago, and together with my team, of which actually quite a few are here as well, we developed Mr. DLib, which stands for Machine Readable Digital Library, and the goal is to offer recommendations as a service. Maybe you are familiar with this as a service concept. You can get machine learning as a service, you can get software as a service, and we have introduced recommendations for digital libraries as a service. The basic concept is simple. If you operate a digital library, this is one of our partners, Soviport. That's just the details of one article in their catalog, and these details are sent to our service, and we return here a list of recommendations. So this is done through a web service. We have a number of partners. Soviport, which unfortunately terminated the entire product a couple of months ago, so that was just a previous pilot partner. We are also delivering recommendations to JabRef. Does anyone here know JabRef? It's a reference management software similar to Mendeley. Okay. No one? Anyway, that's this software here. So it's a desktop software. Mr. Grip can be integrated into websites and into desktop softwares. And we are currently integrating the system into Mediatum. That's the digital library of the Technical University in Munich and in Augsburg. The integration is very simple. Typically, you just need to integrate a couple of lines of JavaScript code in your website, and then everything else works automatically. So whenever a user opens the detail page of an item in your catalog, our service will crawl the content from your website, index the content, and then return recommendations, everything in real time within a second or so. And this architecture illustrates how the process works. Again, at the example with JabRef. So that's the desktop software. Users here organize all the literature. It's like a table. Are you familiar? Who of you is using Mendeley or Zotero or EndNote? Okay, so you're familiar with the basic concept of this. That's like your Mendeley or Zotero, and if you choose an entry here, these are the recommendations. And the way it works, a user selects one article, the request is sent to our service, and then another unique feature is that we A/B test different algorithms, and I'll tell you more about that in a second. So we have multiple recommendation algorithms implemented in our system, and we automatically test which algorithm performs best on your particular platform. And we have something that we call a living lab. So we have external partners who also generate recommendations. So when the request comes here, we randomly choose whether to use our internal recommender system or a living lab partner to whom we forward the request. This partner then generates recommendations, sends them back to us, and we send them back to your digital library, where it's displayed here. And if the user clicks a recommendation, this click is logged, and we use that data to see which recommendations were successful and which were not, and to tune the system and to determine which system was most effective. I mentioned the automatic I/B testing already. This is just some example on the two platforms, JabRef and Soviport, how different algorithms perform. We use click-through rate in this example, so just the ratio of how many recommendations were clicked compared to the number of recommendations being delivered. And what you see, and In the very left column you see a number of algorithms that we use, ranging from word embeddings to very standard Lucene, more like this search, and some other algorithms. And you see the algorithms vary significantly. If you just look here at this column for this partner, JabRef, you see that click-through rate varies between 0.16 and 0.75. So that's roughly 3 or 4 times factor. And you also see that it's not the same algorithm that performs best on both platforms. For JabRef, we use now primarily this algorithm. If we would use the same algorithm for SoapReport, we would achieve a click-through rate of 0.03, very, very low. While if we use this algorithm, that's the highest, so it's 3 times as high. So you see, it's really important that if you develop a recommender system, you need to try out different algorithms and tune them and identify which one is best for your particular platform. Since September 2016, we delivered about 100 million recommendations to our partners, and we release most of the data to enable other researchers in the digital library domain to do research as well. So even if you don't have a digital library, but if you're interested in digital library research, you may have a look at the data set that we released. It's called RART2, the related article recommendation data set. The data set has 94 million log entries. So each recommendation we deliver, we log all the details, like which algorithm did we use, when was it delivered, of course to which partner was it delivered, was it clicked, which algorithm did, like the parameters of the different algorithms, and a lot more things. And we do more things with the recommendations to do additional research. That's just one example. We shuffle the recommendations. So if we have a list of, let's say, 5 recommendations, they are ranked by their relevance, but we shuffle them like randomly to see which recommendations the users click, and we did some research on position bias to find out, do users always click on the first recommendation even if it's the least relevant recommendations? And you see here the click-through rate by rank. Like, if the recommendations are shuffled over many, many thousands of recommendations, you would assume that in an ideal world, researchers would, the users would click always on the most relevant recommendations, and the rank differs, so the click-through rate should be the same on all ranks. That's like the dotted line here, but that's not the case. You see that click-through rate on the first positions is much, much higher than on the other positions. This is one of many examples of research that we do. And that concludes my talk. Thank you very much. Any questions?